Good evening, everybody. This is Rakesh Warkhuntia, and welcome to the new lecture of Fourier Series 1. Today we discuss about Leibnitz Successive Integration. Leibnitz Successive Integration and some basic integrals and orthogonality of sine and cosine function. In lecture 1, we already discussed about periodic functions, even and odd function, and the properties of even and odd function, which is available in the description box. You can check it and download also the PDF. Today we discuss about Leibniz successive integration. Integration of uv dx equals to uv1 minus u1 v2 plus u double dash v3 minus u triple dash v4 up to dotted. Here u be a function and b be a function which product whose and it is can be product or it can be multiplied uv dx. It can also be calculated by applying by part integration by parts rule, Italy or Eilert rule. You can also calculate by applying integration by parts, Italy or Eilert rule. But here, when we are applying Leibniz successive integration, the method can be so easy and it can be used for our Fourier series. Here u be a function which is an algebraic function like x to the power n, and v be a function which is like a function e to the power x, exponential function cos x, sin x. Here only u be the algebraic function x to the power n and v be the function e to the power x or cos x or sin x. All different function by Leibniz successive integration cannot be applied. Leibniz successive integration can only be applied when u be the algebraic function like x to the power n and v be the function like exponentials cos x, sin x, whose successive integral you can be calculated. So, for this function we can apply on Leibniz successive integral. For another function we cannot be applied Leibniz successive integral. Here u dash be the du by dx or derivative of u double dash be the derivative of u dash, u triple dash be the derivative of u double dash, and v1 be the integration of v2 be the integration of v1 and v3 be the integration of v2. This is the successive integral. For example, for consider some example 1, integration, example 1, integration of x square sin x square sin x. Here x is here u be the x square and v be the sin x. We apply Leibniz successive integral, which is u v1 minus u dash v2 up to. So here u x square v1 means integration of v, that is sine integration minus cos x minus u dash v2, u dash matlab derivative of x square, it means 2x, and v2 matlab integration of v1, that is integration of minus cos x, integration of minus cos x is minus sin x, and third part plus u double dash matlab derivative of 2x, that is 2, v3 matlab integration of minus sin x, that is cos x. And for the next term, derivative of 2 to be a constant function, so constant derivative of a constant function is 0 and next term can be cancelled out. So the integration of x square sin x dx like this, x square minus cos x, x square minus cos x minus 2x sin x minus plus 2 cos x. Consider another example. The second example. Here the first example can be applied, and for second example, integration of x cube cos 2x cos 2x. Here we applied Leibniz successive integration, that is uv1 means here x cube is u and cos 2x be the v function. So uv1 u x cube v1 matlab integration of cos 2x, and integration of cos 2x will be sin 2x divided by 2 minus u dash v2 minus u dash v2 मतलब minus u dash मतलब derivative of x cube, that is 3x square v2 मतलब integration of sin 2x by 2, that is minus cos 2x divided by 4. Next, plus u double dash v3. U double dash means integration of 3x square, that is 6x, and v3 matlab integration of minus cos 2x by 4, that is minus sin 2x divided by 8. Next term will be minus u3 v4 minus u3 matlab integration derivative of 6x, that is 6, and v4 matlab integration of minus sin 2x by 8, that is cos 2x divided by 16. In such pattern, you can apply Leibniz successive integral. This is the various examples of Leibniz successive integral. Then we can calculate, but we can remember some basic integral for which we applied in Fourier series. Here we study about some basic integral. We have sin n phi equals to 0 for n belongs to integer, means sin 0 is 0, sin phi 0, sin 2 phi 0, sin 3 phi 0, up to sin n pi equals to 0. But cos n pi equals to minus 1 to the power n into minus 1 to the power n phi minus 1 to the power n, where n belongs to I. If n will be 0, then it becomes cos 0. We know that the value of cos 0 is 1. So minus 1 to the power 0 is 1. When n becomes 1, it converted to cos pi. Here n equals to 1, minus 1 to the power 1 equals to minus 1. And we know that the value of cos pi is minus 1. So, cos even multiple of a pi is 1. Matlab cos 0 equals to cos 2 pi equals to cos 4 pi equals to cos 6 pi. Even multiple of a pi having cos is plus 1. But the odd multiple of pi, that is cos pi equals to cos 3 pi equals to cos 5 pi equals to cos 7 pi, etc., having values minus 1. And the first integral is sine integration minus pi to pi sine n pi dx equals to integration minus pi to pi cos n pi dx equals to 0. Let us now prove it. Let us now prove it. Let us now prove it. Here, integration minus pi to pi sine n pi dx equals to sine n pi integration minus cos n phi divided by n limit minus pi to pi. Here n be the constant and the constant can be take outside, so 1 by n minus cos n pi minus pi to pi. So 1 by n equals to minus, we put the limits, that is in place of n, in place of n phi cos n pi in place of cos nx, here sin nx n pi x or cos n pi x, we have used some basic integration, that is sin mx dx, the sin mx dx, sin mx dx cos mx dx having value 0. Let us now check it. Sin mx dx having value minus m. Here we are putting the limiting value in place of x, upward limit, minus in place of x, lower limit. So we have minus cos m pi minus, already minus, the minus plus cos m minus pi means minus m pi, and we have cos minus theta will be minus cos theta. Minus cos minus theta will be cos theta. So 1 by m equals to minus cos m pi plus cos m pi. By using this property cos minus theta equals to cos theta, ASTC rule, when the value is fourth quadrant, here cos and sec will be positive. So using this property we have like this, that is minus cos pi cancel, so 1 by m into 0 equals to 0. For similar pattern, you can prove that cos mx dx integration minus pi to pi equals to 0. For similar pattern, you can check it. Now the second integral, e to the power ax sin bx dx equals to e to the power ax divided by a square plus b square integration a sin bx minus b cos bx. Similarly, integration of e to the power ax cos bx dx equals to e to the power ax divided by a square plus b square whole into a cos bx plus b sin bx. This can be derived or proved by using by parts, integration by parts, by applying Italy or Illit rule. Remember, here the formula having e to the power ax divided by a square plus b square a sin bx, then minus of that function means minus of derivative of that function, means sin bx derivative is minus b cos bx. Similar pattern you can check it by applying by parts rule. Now the another property is the orthogonality of a sine and cosine function. Sine and cosine function orthogonality property, integration minus pi to pi sin mx cos mx dx equals to 0 for all values of m and integer, where m and n integer greater than 1. Similarly, cos integration minus pi to pi cos mx cos nx dx equals to integration minus pi to pi sin mx into sin nx dx equals to pi delta mn. Here delta mn is the Kronecker delta. Delta mn, where delta mn is the Kronecker delta. Kronecker delta whose values is delta mn is called as Kronecker delta whose values is 0 for m is not equals to n and 1 for m is equals to n, where for m and n is not equals to 0. If m is not equals to n, then the Kronecker delta becomes 0. If m equals to n, then the Kronecker delta will be 1. We can prove it. We can prove the orthogonality condition of sine and cosine function. Let us now prove orthogonality proof of 1. Let us now prove the integration minus pi to pi sin mx cos into cos nx dx equals to 0 for all. This symbol is indicates for all mn is greater than 1. By applying standard trigonometry equation, sin a plus b plus sin a minus b, we have 2 sin a into cos b. By applying the standard trigonometry equation, here LHS sin mx into cos nx integration minus pi to pi. Simple. Sin mx cos nx dx. Let mx will be a and nx will be b. A will be mx and b will be nx. Then the standard equation says that the two can be taking left side is divided. So we have 1 by 2 integration, it will be integration minus pi to pi here sin a plus b, a equals to mx and b is the nx. So a plus b matlab m plus n x dx plus sin integration minus pi to pi sin a minus b matlab m minus n x dx. Here we have integration minus pi to pi sin m plus n x dx. This value will be 0 and also this value will be 0 by applying the basic integrals, that is sin mx dx. Integration minus pi to pi will be 0. So here this value is 0 plus 0 will be 0. Proved. In similar pattern, we can also prove integration minus pi to pi cos mx into cos nx dx equals to pi delta mn. In a similar pattern. Proof for two orthogonality condition. Proof for two properties. By using standard trigonometry condition, that is cos a plus b plus cos a minus b equals to 2 cos a into cos b, 2 cos a into cos b. So cos a into cos b, that is LHS integration minus pi to pi cos mx into cos nx dx. Let us put mx is 1 and nx will be b. Here a will be mx and b will be nx. Then we have 1 by 2 is equals to integration minus pi to pi cos a plus b मतलब cos m plus n x dx plus cos m minus n x dx integration minus pi to pi. So half here the value integration minus pi to pi cos m plus n x dx will be 0 and cos m minus n x dx will be 0. So that value becomes 0. If m is not equals to n, if m is not equals to n, if m is not equals to n, then that value becomes 0. That value becomes 0. If m is equals to n, then that part can be cancelled out. So here we assume that m is not equals to n, then that value becomes 0 by applying this identity integration minus pi to pi cos mx dx equals to 0. So here the Kronecker delta, it means pi delta mn. If m is not equals to n, then delta mn will be 0. So pi into 0 will be 0. As for m equals to n, then integration minus pi to pi cos mx cos nx cos mx into cos nx dx. Here n equals to m, so we put cos mx and which becomes integration minus pi to pi cos square mx dx. And by applying the identity rule, cos 2 theta equals to 2 cos square theta minus 1. So cos square theta will be 1 minus 1, left side 1 plus cos 2 theta divided by 2. So by using this identity cos square theta equals to 1 plus cos theta by 2, here theta will be mx. So we have integration minus pi to pi 1 plus cos 2 mx divided by 2 integration. By using this identity you can apply. Here 1 by 2 will be constant, taking outside from the integration, and integration minus pi to pi 1 dx will be dx plus integration cos 2 mx dx minus pi to pi. Check it. You can download or check from the description box. Here we have half integration of dx. Integration of dx will be x and limit minus pi to pi plus integration of cos 2 mx will be sine 2 mx divided by 2 limit minus pi to pi. Half using the integrational formula, that is in place of x we can write upper limit minus lower limit. So pi minus lower limit will be minus pi, 1 by 2m. 1 by 2m is taking outside. We have sine 2mx. In place of x we can put upper limit minus lower limit. We have cos 2m pi minus sine 2m minus pi, we have half pi minus pi will be 2 pi plus 1 by 2m sine 2m pi. We know that sine minus theta equals to minus sine theta. By applying this identity, we have plus sine 2m pi. Here 1 by 2 pi plus 1 by 2m sine 2m pi. We know that sine n pi equals to 0. Sine n pi equals to 0. So here sine 2m pi will be 0 plus sine 2m pi will be 0. So 0 plus 0 equals to 0. 1 plus 2m that is 1 by 2 into 2 pi plus 0 equals to pi. So if m equals to n, then you can prove that integration minus pi to pi cos mx into cos nx equals to pi delta mn, means Kronecker delta. If m equals to n, then the Kronecker delta becomes 1. So in place of del mn, you can put 1, that is pi into 1 equals to pi. Proved it. In such similar pattern, you also can prove that sin mx into sin nx equals to pi delta mn by applying the trigonometric identity, that is cos a plus b minus cos a minus b, that is minus 2 sin a into sin b. So this part you can check it. Thank you. Like, share and subscribe my channel. Next class we discuss about Fourier Series Lecture 3. These two classes are only introductory idea about the Fourier series, that is the terms connected to the Fourier series. Thank you.